Okay, so this is the circular motion lab that we did with the helicopters, all right? I'm just going to make up numbers here, so if they don't match your numbers, that's okay, but we'll get them anyway, all right? So here's what we're going to do. First step, we're trying to find what was the tension in the string. And as many of you pointed out, there is no formula specifically for tension. So the goal, again, was to find the tension in the string. For those of y'all that weren't here, a little bit more setup. We had a point on the ceiling, and we had a string hanging down. There was a helicopter that was going in a circle, and what we were trying to do is to figure out this tension in the string. Pretend this is 3D. It's spinning in a circle from the ceiling. If you need me to demonstrate, I'll be glad to demonstrate. All right. So what we basically knew to begin with is that the string was pulling on the helicopter this direction. If this is our helicopter right here, pretend that we know I can't draw, so we'll just say that that's the helicopter, and this blue force is the tension. If we look at it, there were two other forces acting on it. One of them was the centripetal force, keeping it in the circle, and the third force acting on it was, of course, the force of gravity. And so we wanted to know the tension. Well, to begin with, before we get into the problem, let's just look. If the tension is pulling this way, then that means there's two components to it. It means that there is a centripetal force component keeping the thing in the circle, and it's also having to resist the force of gravity. So basically it looks like this. Now technically it is the opposite of the force of gravity, so I suppose that should be negative Fg, but there you go. The tension is is keeping it up in the air by resisting the force of gravity and keeping it in the circle by being the centripetal force. So essentially we can write this as the tension in the x direction is equal to the centripetal force, and the tension in the y direction is equal to the force of gravity. Okay, so now we're ready to get started. First thing we need to do is to figure out what the centripetal force is. So the centripetal force is equal to mv squared divided by r. And I started by giving you the mass of the helicopter. So the mass of the helicopter was 0.3 kilograms. Now, I don't know what you did to find the radius in the class, but what I did, let's just forget about what we did to find it, because that's not what's really important. We just need to have a radius. So let's say that your radius that you found was 0.65 meters. All right? I didn't pick that for any other reason than it just looks like it probably is close. And then the other thing we needed to do is to figure out the time it took for one rotation. So what I tried to get you to do was to figure out the time for 10 rotations. Let's just say that the time for 10 rotations for yours was 15 seconds. Well, then the time for one rotation would be equal to 1.5 seconds. If it did 10 rotations in 15 seconds, then for one rotation it would take 1.5 seconds. All right. So now we have a time, we have a radius, we have a mass. We're trying to figure out the centripetal force. So of course we don't have this right here. We have mass and we have radius, but we don't have the v squared. So how do I find the v squared? Well, if we look at it, let's just pretend we're looking at the helicopter from above. Then we have this circle right here that it's making, okay? Now, what distance is it covering? Well, it should be pretty apparent to you that it's covering the circle, and the circumference of the circle would be the distance it's covering. So our velocity equals 2 pi r divided by the time it takes to make one lap. So we got v is equal to 2 times 3.14 times, in our case, 0.65 seconds, divided by 1.5 seconds. And so if we do that, we get 2 times 3.14 times 0.65 divided by 1.5. We should get 2.7 meters per second. Okay, and this is the velocity that our helicopter is going round and around. But now we have to find the centripetal force. So we know now that we got the velocity, so that's good. So we can just plug this in. Fc equals 0.3 times 2.7 squared divided by 0.65. Alright, and so we get 0.3 times 2.7 squared divided by 0.65. And so the centripetal force is equal to 3.36 newtons. Okay, that's the centripetal force. So let's go back to the first page. The centripetal force is equal to 3.36. So that means that's my tension in the X. So this is now equal to 3.36. Now I need to figure out the force of gravity. Alright, this should be a little easier. The force of gravity, if you'll remember, is just equal to mass times mass times negative 10. And so if we're trying to solve for this, you would just do force of gravity equals 0.3 kilograms times negative 10 meters per second squared, and you would get 3 newtons, negative 3 newtons. Okay, so the force of gravity is equal to negative 3 newtons. But our tension in the Y is equal to the negative of the force of gravity because it's resisting gravity, so that's equal to just 3 newtons. Alright, now you should see fairly clearly that the tension is going to be equal to the, you're going to have to do the Pythagorean theorem to figure this out. So we've got a centripetal force and a force of gravity, 3.36 and 3. So we got tension here, we have 3 newtons here, and we have 3.36 here. Okay, 3.36 newtons. So if we're trying to figure out the tension in this string, we just have to do tension is equal to the square root of 3 squared plus 3.36 squared. And so if we try to type that in the calculator, we get 3 squared plus 3.36 squared, and we get 20.3 newtons, and then we got to square root it, 4.5. Tension is equal to 4.5 newtons. Okay, so that's our answer. And that's how we do the circular motion lab. Hopefully this helps you, and hopefully you'll have a good day.